talk about a couple of different rules for probability. We'll start with the addition rule. The addition rule is when we deal with compound events. A compound event is any event that combines two or more events. The notation we use is P of A, event A happening, or event B happening. So for example, let's suppose we are rolling a pair of dice. And we'll consider two events. Event A is the event that the dice add up to 8. So 2 and 6, or 3 and 5, or 4 and 4. And let's let event B be that one of the dice is a 5. So 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5. These two things can happen independently of each other, or these two things could happen at the same time, rolling a 5 and rolling a 3. The probability that event A happens or event B happens is written as P of A or B, or P of A union B. Let's do an example. We're going to find the probability of picking a subject who lied or a subject who the polygraph test says they lied. So we have a graph here of people who lied or did not lie, and also the polygraph said that they lied and the polygraph said that they didn't lie. Let's call these each events. Let's say event B is the people who the polygraph says that they lied, and event A is the subjects who lied. So to figure out how many people are in event A and how many people are in event B, let's see, for event A, the number of subjects who actually lied would be the second column, the column on the right, did actually lie. So 42 people did actually lie and the polygraph said they lied. And 9 people did actually lie, but the polygraph said they didn't lie. So for a total of 51 people that did actually lie. For event B, the polygraph says they lied. That's the first row. 15 people did not lie, but the polygraph said they did. And 42 people did actually lie, and the polygraph said that they did. So that's a total of 57 people where the polygraph said they lied. To find the probability that both events happened, we also need to figure out how many people total this event is talking about. So to get that, we need to add up the other remaining rows or columns. So for the people that did not actually lie, we have 15 plus 32 for a total of 47. And for the polygraphs that said they didn't lie, we have 32 plus 9 is 41. The total number of people in this test can be found by either adding 57 plus 41, which is 98, or 47 plus 51, which is also 98. Here's a really common mistake. Frequently, people think that finding the probability of event A or event B is found by finding the probability of A and adding it to the probability of B. So finding how many of the simple events of A divided by the total number of simple events in the sample space, and adding it to the same thing with B, the number of events in B divided by the sample space. But the problem with this is, in this example, that would be 51 people did actually lie out of 98 total. So the probability that somebody did actually lie in this study is 51 over 98. And the probability that the polygraph said that they lied is 57 over 98. But this is incorrect. We're double counting the people that did actually lie, and the polygraph also said that they lied. Those 42 people, we're double counting them. So here's the rule that we're going to use to do this example and these problems. The addition rule for probability. To find the probability that event A happened or B happened, we add the two probabilities together, P of A plus P of B, and then we need to subtract off wherever we might have double counted. So subtract off the probability that event A and B both happened. In symbols, that looks like P of A union B equals P of A plus P of B minus P of A, that upside down U is called intersection B. A definition that's important. Two events A and B are disjoint. We also call this mutually exclusive if they cannot occur at the same time. If you're flipping a coin, for example, you cannot roll a heads and a tails at the same time. I cannot be in my office working and at home at the same time. Those are disjoint events. If two events are disjoint, then the probability of A and B happening at the same time, P of A and B, is 0. The probability of me being both in my office and at home at the same time is 0. The probability of flipping a coin and getting a heads and a tails is 0. So back to our example. If we want to find the probability of picking a subject who lied or who the polygraph says they lied, we're going to use our addition rule. So the probability that a subject lied plus the probability that the polygraph says they did minus where we double counted, the probability that the subject did lie and the polygraph said they did. So that would be 51 out of 98 people actually did lie plus 57 out of 98 people the polygraph said that they lied. But we've counted the 42 twice, so minus the people that actually did lie and the polygraph said they did, 42 over 98. When we add all those up, 51 plus 57 minus 42, we get 66 over 98. And like all probabilities, we can write it as a fraction or as a decimal, 0.6735. Okay, example 2. If we roll 2 die, then let's let A be the event that we roll a sum of 8. And let's let event B be the event that one of the dice is a 1. Let's find the probability that event A or event B happens. So either we roll a sum of 8 or one of the dice is a 1. Okay, so we're going to use our addition rule. And here is a list of all of the possibilities for rolling 2 dice. Both are 1s. The first is a 1, the second is a 2, the first is a 1, the second is a 3, and so on. If we find all of the possible dice rolls where the sum is an 8, we will get these 5 possibilities. The first is a 6, the second is a 2, the first die is a 5 and the second die is a 3. They're both 4s, and the first is a 3, second is a 5, the first is a 2, the second is a 6. So that is 5 total. If we find all the events where one of the dice is a 1, we'll get the top column, or the top row rather, where the first dice rolls a 1, or the first column where the second dice rolls a 1. And if we count all these up, we have 11 total where one of the dice is a 1. So 11 out of 36 total. And the probability that the total sum of the 2 dice is 8, but one of the dice is a 1, that's 0. Notice we don't have any overlap. There's no way to roll 2 dice whose numbers go 1 to 6 and have a sum of 8 where one of those dice is a 1. So here's what we're going to get. 5 out of 36 for the probability that the sum is 8. plus 11 out of 36 for the probability that one of the dice is a 1, minus 0 out of 36 because those two events are disjoint. 5 over 36 plus 11 over 36 is 16 over 36, which is equal to 0.4444. Okay, let's take a look at whether events are disjoint or not. So first example, it's the two events arriving late for your next class or arriving early for your next class. Cannot do both at the same time, so these two events are disjoint. The probability that both happen at the same time is 0. Second set of events, randomly selecting a drug screening result and getting one that is a false positive. In the other event, randomly selecting a drug screening result and getting one from someone who does not use drugs. These events are not disjoint. It's possible that when you randomly select a drug screening result, you could get one that is a false positive from someone who does not use drugs. So those two events are not disjoint. And then finally, the two events, your refrigerator doesn't work, and the second event, your television doesn't work. These are definitely not disjoint. They could unfortunately be happening at the same time. So if we think of it pictorially, let's have the blue circle be the probability of event A happening, and the red circle be the probability of event B happening. If these two circles are separate from each other, this is what disjoint events look like. And the probability of event A happening or B happening would just be the two probabilities added together. But let's say that there is some overlap, that the two events are not disjoint. If I were to draw a picture of what that looks like, these two circles for the probability of event A happening and the probability of event B happening, if they're not disjoint, they have some overlap. So in that case, we have to subtract off the middle part where event